So good day and welcome to the innovative steps for the path to net zero. It's intended to show you how delivering high performance schools within a conventional budget is really achievable. We're very excited about A4LE's opportunity to give everyone this virtual conference, and we hope you enjoy it. As a start, we'd like to introduce our team. I'm Richard Higgins with BLRB Architects.
Hi there, I'm Ellen Shepard. I'm an outreach manager with Energy Trust New Buildings Program.
Hi everyone, my name is Rick Flacco and I'm also an outreach manager with Energy Trust of Oregon's New Buildings Program and the K through 12 sector lead.
Hi everybody, I'm Ruan Jayaweera. I'm an associate principal and mechanical engineer with PAE.
So the agenda is very straightforward today. We're going to give you an overview of the projects. They're plural. We're going to give you some background on the school district itself. We're going to talk about how the school district really tried to do a whole child development. It was really an integrated program of design and teaching and learning. Integral to the school district was sustainability, how they can make their buildings more efficient and really become teaching opportunities for their students. And then finally, we're going to give you a 360 view of just really how we think the overall implications factored into the design of the buildings. So now we will give you the overview of the school district itself. We'll start with telling you it is in the east side of East Multnomah County in Portland, Oregon. It serves about 10,800 students in K-12. But what's really interesting, it's touches 5 different municipalities. City of Portland, City of Gresham, Fairview, Wood Village, and Troutdale. So these 3 schools really are pretty diverse in their address and their students. It's right along the Columbia River, and it has 84 highway going through it. So it is partially bisected, but it is serving 5 different communities. The first school is Wilkes Elementary. It actually is one of the first schools in the Portland metro area. It was a pioneer school. There's even a plaque commemorating the pioneer child that was actually relocated for the installation of I-84. I have an older friend who actually went to the original school and has fun conversation about how he took away his school. But this is really a school for new pioneers, a very diverse community of students from all over the world. In fact, they have a map with pins all over it that shows all of the locations, all of the places around the world from which these families have immigrated. The next one is Fairview Elementary. It has a very diverse background as well, but its unique characteristic, it was this red brick school. And it's in a bedroom community, which doesn't have a downtown per se, does have some pretty major arteries that go around its boundaries. But it is some older homes, more established community in the Portland area, but it is actually in the town of Fairview. Very unique. They serve one of the largest Section 8 housing developments in the state of Oregon. So again, pretty diverse population. Lastly is Troutdale. Troutdale Elementary is right at the gateway to the Columbia Gorge and Scenic Highway 30. Its historic downtown really has its own kind of character. And the school was up on the hill, a very classic school, but it was the desirable school because of its proximity to the gorge. One of the first steps was to create the guiding principles for the project, and the school district put as number 1 and number 2 is that these buildings needed to be learner focused, and they needed to be safe environments for obvious reasons. Some of their subsections were flexible and adaptable, which are pretty commonplace. Meaningful collaboration, community spaces, and that's really what we're going to focus a little bit on, but also stewardship and sustainability for the environment and it really, they took it to another level. We appreciate that. And then of course, they are 3 diverse communities, so they really honor the communities in which they're located. And that's pretty hard to do when you had 3 concurrent schools being designed and built. And it wasn't a matter of creating a prototype. It wasn't a kit of parts. It was more creating equity between all 3 schools. And as I mentioned, concurrent construction, they were all occupied sites. The kids did not leave the site. Schools were being built in the playgrounds or in the or an adjacent parking lot. So they chose to save money. So let's do that again. The school district chose to build the schools on the current sites to really not to disrupt the community any more than construction might cause the disruption. They also chose the same products and the same systems for all 3 schools. So they had the economy of having similar systems and adding stock in those replacement parts, even though they had 2 contractors building those projects. Same construction type, and as you'll see, they have very many similarities, but they all had to be very, very different. They all had to be site specific relative to the orientation, the parking lots, the drop off, and the bus parking. Here's a floor plan of Troutdale. It is one of more of the unique plans because of its very constricted site. It was on like 6 acres and it really had to be built in 2 phases because the portion you see up at the right-hand corner, which is the gymnasium, actually had to be built after they demolished the original school. As you can see, the parts to the left, the class pods, really were the beginning of construction, and they built it and went into the direction toward the gymnasium. The common threads to all 3 plans are the pod configurations with the flexible learning spaces in the middle and their own kind of focused areas of restrooms and some breakout spaces. And then the elements of media center and cafeteria and gymnasium were equally the parts that you could move and rotate. On the upstairs, you can see those pods were duplicated. And then of course, in this case, the media center was on top of the administrative areas. Very compact, but lots of daylighting. And we'll talk a little bit about that L classroom configuration. I'm going to show you a few images of really what these buildings kind of look like, and hopefully you'll get the sense of their diversity. This is Troutdale, again, a little bit warmer colors because it is closer to the gorge and they wanted some semblance of more of a rustic feel. But what's really important is they had drop off at the front of the door for parents who drop off their kids, a static parking lot in front of that. And the buses were on the street to the left out of the picture, and they queued up right on the street. In smaller communities, you can actually use these pieces to maximize your site. So you could actually put the parking on the public street. That public street access was connected by this walkway out of one of the center of the pods. And of course, it had to be covered to address our Oregon climate. The media center is really important to these communities because they use those as one of their community spaces. And these little windows at a kid level really again tends to support the notion that this is really focused on kids and kid learners. This is the Fairview, which had the red brick schoolhouse. So the new building has red brick. Again, it's a small community, and so they wanted an outdoor assembly space. So this little amphitheater at the entryway is a place for community gatherings. It is pretty dramatic entry. Again, drop off at the front door and static parking for teachers and visitors at the front. Again, just tiny, tiny sites. The background of this picture are the mural on the wall. And each one of these schools had their own mural that was created specifically about the history and the heritage of their school. And it had very colorful, decorative aspect to the entrance lobby of these schools. Obviously, the transparency, visibility between the cafeteria, the commons into that main hallway was really important to making these schools open and connected to the community. Wilkes Elementary was on a bigger site, but it did have that same need for parking at the front and drop off, because many of the parents dropped their kids off from their private vehicles. The street on the other side of the site is where the buses queue up right on the curb. And interestingly enough, there is the circulation path for the buses had to go around the building and go back out the same way they came in, so that they didn't have to cross a railroad crossing, which slows down the circulation, and they have to stop at each one of those. So a very important design element was the site buses and the flow of traffic. This is one of those flexible learning areas. In this case, they've got furnishings and group areas and even some computers. Other areas is a little more open. They can have a group or grade level congregating spaces. This is the inside of Wilkes, as I mentioned. And again, they have very large after school program, and there's needs to be more places for kids to hang out and still be visible and waiting for their parents to come pick them up. So this was these designs were all motivated by the whole child development. I want to show you a little bit about how we think that works. Safe environment, very important. If there's one place kids need to go to be safe, it's school. Be able to monitor the access and the entry. You have secured vestibules to monitor who comes and goes. Grade levels are congregated around this common area. So you have grades, kids, cohorts of the same age group, all in that same area of development. And then they really tried to make it part of the greater community. These three communities are all in a metropolitan area, but they have their own distinct characteristics. And so that was really important to the school district, make sure these schools belong to those smaller communities. The Fadel Studio, the research shows that it really creates more spaces than just a rectangular or square room or rectangular room. You can actually break out instruction. You can have more one-on or group instruction or plenary presentations. You can take a group of kids and put them in the smaller niche, like a story area. And then of course, it gives you that other area where you can set up for independent learners who really don't need the help of the teacher, and they can really create more on their own. Large group rooms, this is an illustration how that commons area is actually used as a group area. There's also some breakout areas for direct instruction that you can pull them out, pull kids out of the program space and into these smaller rooms and still have that visual connection to the bigger room. And all the pods were really broken into grade levels, and changes in counter heights and some of the features, each of those were incorporated into each grade level pods to reflect the needs of those age group of students. The school district has a very high percentage of free and reduced lunch programs, and so they offer breakfast and lunch to all students, just to remove the stigma of who's on free and reduced and who has to pay. And they also provide additional family support services. There are some special rooms that provide, they're community restrooms that have showers, washing machines, and family bathrooms. It's not a big program, but it is available to the community when they need it. Outdoor play areas, before school programs, after school programs, all these spaces have to be provided with the right kind of support, whether it's a covered play area or it's the play surface on which the kids are interacting. I mentioned the wall mural. This shows you the size of it, and as I said, each one of these were created. This happens for the school. Excuse me. This one happens to be Troutdale, which is the gateway to the gorge. And as you see, there's Vista House on the left-hand side, which is a really important landmark in the Columbia River Gorge. Because they are community spaces used constantly, they had to be full-size gyms, oversized and flexible so that they could accommodate many, many programs. Each space did have a separate maker space that you could provide a number of different programs. It could be an art program. It could be a maker space. It could even be community spaces where they can come in and share multicultural dinners. In fact, at Wilkes, that is the way they operated this room, is that community came together and they had times where they would actually share their cultural differences over food. And even though they couldn't speak the same language, but they did have a congregating place with a small kitchenette. So we've talked about how the schools really have been developed and how they really address the needs of the learner, but it goes one step forward, as you saw, with the goals of the school district, because that's really how they prescribed an integration of sustainability, and we'll show you how that works. So the district gave us some very specific goals at the beginning of the process. And that was to use all the resources available to create and design a very, very efficient, energy efficient building. Some of the elements to that were daylight harvesting, but in addition to daylight harvesting was really harvesting some of the temperate climate that we have here in Oregon. So with that, I'd like to give Rick Flacco, introduce Rick Flacco again. And if you'll pick it up at this point, Rick, I'd appreciate it.
Well, thank you very much for the intro, Richard. And hello, everyone. Thank you. Thank you. My name is Rick Flacco. I'm the K-12 sector lead for Energy Trust of Oregon's New Buildings program. It's so great to be here and have the opportunity to introduce Energy Trust, our Path to Net Zero program, and we'll also be talking about our work with Reynolds School District specifically. Energy Trust is an independent nonprofit organization dedicated to helping utility customers invest in and benefit from energy efficiency and clean renewable power by providing cash incentives and services for energy efficiency improvements. This helps save energy, generate power, and manage costs in homes, businesses, and communities. Energy Trust is funded by a small percentage charge on the utility bills of Portland General Electric, Pacific Power, Northwest Natural, Cascade Natural Gas, and DeVista customers. We also serve customers of Northwest Natural in Washington State. Now, I'd like to talk a little bit about one of our primary offerings of the New Buildings program, Path to Net Zero. Project teams and districts who have aggressive energy efficiency goals measure their building's performance using a metric called EUI, or Energy Use Intensity. EUI measures the overall energy usage of a site. When an EUI, as proved by an energy model, is in alignment with Architecture 2030 guidelines, projects become eligible for our Path to Net Zero program. To kick things off, we offer up to $6,000 for conducting an early design charrette when projects are in the schematic design phase. This meeting's a great place to discuss the various end uses which make up the building's total energy usage. Using this collaborative approach, we often find opportunities to improve aspects of the design and are able to have a good holistic discussion to ensure that everyone's on the same page moving into the next phases of construction. We also pay 60% up to $40,000 for early design studies, including shoebox modeling, CFD analysis, and daylighting studies. Also included in this bucket is the incentive for the whole building energy model. And this is what the final incentives are based on. Path to Net Zero offers elevated final installation incentives of 40 cents per kilowatt and $1.20 per therm of annual energy savings. We also offer additional incentives in the post-occupancy phase for both energy metering and zero energy certification with the International Living Future Institute. Path to Net Zero helps project teams and school districts who want to be at the forefront of energy efficient design stay ahead of the curve when implementing their long-term facility plans. Now, I'd like to hand it over to Ellen Shepard. Ellen's been working with the New Buildings program for nearly 11 years, and she was the one who originally helped with the cash incentives on the Reynolds School District elementary schools. Ellen?
Thanks so much, Rick. That was a great overview of Energy Trust and our Path to Net Zero program. I'm Ellen Shepard. I work with Rick at Energy Trust New Buildings program. I'm an outreach manager, and I worked with Reynolds School District on their bond projects, including the 3 schools that Richard mentioned earlier. What was great was that the district enrolled the projects as soon as their bond passed, which is a key to maximizing incentives with Energy Trust, including early design assistance. As Rick mentioned, this is an offering that supports an early design charrette with the team. And it's just an opportunity to discuss design strategies, energy measures, and how those all align with incentives. So at those meetings with the district, when we were talking about the 3 schools, the owner shifted to the Path to Net Zero program and committed to a high performance direction that allowed them to achieve 70% savings over a standard school building in the Pacific Northwest. And in addition to early design, we were also able to give them incentives for technical assistance, as Rick mentioned, energy modeling, daylighting studies, and that also helped inform the design and confirm the district goals. The measures that we were able to incentivize in these projects were variable refrigerant flow with heat recovery, LED lighting, advanced daylighting, high efficiency water heating, and solar ready construction. And Ruwan's going to talk more about those in just a minute. Through this efficient design, Energy Trust was able to bring about $150,000 per school for incentives. And you can see on the slide that contributes to about $61,000 a year in electric and gas savings. And that's ongoing savings that the district will be achieving every year. And that equates to about 250,000 kilowatt hours and about 1,600 therms. So again, that's just money that they're avoiding having to spend that they can put more into their programs. All right, so on to Ruwan, who's going to talk more about the mechanical design and energy measures. Thanks so much.
Thanks, Ellen. So in the process of working with the school district, Richard, and the ETO, we went through several scenarios of goal setting. And what we ended up with is trying to get to a net zero energy, or at least a net zero energy ready school. And really what helped guide that is the district's guiding principles that Richard kind of talked about. We looked at different HVAC options, looking at the envelope, looking at natural ventilation, and really doing modeling to provide the data to the district to make a decision. Next slide. So this is an example of kind of the energy use goal setting data that we provide to the district and the team, design team early on, really, at SD phase. And we like to keep it simple. So you can see that there's a code baseline. What if we designed this school to whatever the minimum code is, maybe a little bit better, and then what's the best? And the best is always for us, how can we get to net zero energy? And as Rick and Ellen pointed out, to get to ETO's Path to Net Zero Energy program, you have to meet the Architecture 2030 target at that time. And at that time, you can see we were somewhere around 25 EUI, and Rick talked about what EUI is. And we were showing, according to our computerized models, that we were able to get below that 2030 target with the best approach. And that would put us in the Path to Net Zero Energy program with all the increased incentives and so on. And so along with this data, we also provided payback analysis that showed that we should be able to get a good payback within 5 to 10 years, something like that. And that really piqued the interest of the district, and they were interested in moving forward with that approach as long as we can answer some additional questions. So the next thing we did was we did a quick climate analysis. So one of the first things I like to show clients is how many hours in different outside air temperature bins do we see in our climate. So in this case, it's Portland. And this just shows number of hours in the vertical axis and 5-degree bins of outside air temperature on the x-axis. And so it shows that in Portland, normally we're between, lots of our hours are between 35 degrees and 70 degrees. It gets hot, to 95 to 100, but not a lot of hours. And then the different colors shows, during which hours do we need to actively heat and actively cool. So below 55 degrees, we're normally actively heating, and above 70 degrees, outside air temperature, we're normally actively cooling. And everywhere in between, we're not really actively heating or cooling with the HVAC system. Now, this is with a code level envelope. So what happens if we increase that envelope to a passive level, which means increasing R values, adding solar heat control, so on. Next slide shows that by increasing the envelope performance, you can increase the percent of hours in a year that building can operate in that passive cooling area. In fact, we can get to about 83% of the year with comfortable temperatures in the space, actually doing no active heating or cooling. So this reduces the amount of heating required to anything below 40 degrees outside temperature, and heating to anything above 80 degrees outside air temperature. So significant reduction in HVAC capacity. The other point here is that you can also see that the cooling zone, active cooling zone, is only 3% of the year. So this is a point in a design where you talk about, hey, 3% of the year is the only time you need active cooling. Do you want to pay upfront costs to put in an active cooling system for 3% of the year? So now it becomes a cost benefit analysis whether you want to do that or not. It's an interesting thought. So what we initially do is we do that energy model, like I said, then we start to dive in to that data to try to figure out what's the most cost-effective way to reduce energy. And one of the first steps is doing an energy use breakdown. Where is the annual energy use happening? And typically in our climate, in K-12 work, the energy is in heating, just because the majority of the program occurs when it's colder outside. There's a lot of outside air that we're bringing in. So there's a lot of, and our climate is on the colder side. So that's why the heating energy is important. And it's the bigger piece of the pie. So we want to be cost effective in where we focus our time and energy and frankly, our dollars. And that's why we want to look at this and say, okay, let's focus on that big piece of the pie, which is the heating. So next slide actually shows that heating piece of the pie broken down even further. Now we want to look at that heating and say, okay, we want to tackle the heating, but where do we tackle the heating, right? So now this tells us exactly what components in the building do we want to look at if we want to tackle that heating piece. And usually it's the windows. The windows lose a lot of the heat. And then it's infiltration, any leakage into the building that occurs through cracks and so on in the building facade. So we want to focus mainly on those two. Of course, we want to have good R values, increased R values at the windows and the walls, but we want to focus most of our efforts on the windows and the infiltration. So next slide. So what that gets us to is this passive heating and passive cooling approach. And it goes back to that climate slide that we talked about. I said, the cooling is energies, or the cooling amount of cooling hours is only 3% of the hours of a year if you're able to really get a good envelope. And so we had that conversation, and that really piqued the district's interest. It's like, well, if you can not pay for an HVAC system, great, right? And you invest the money into the envelope, which is going to last 50 years or more, compared to investing the money into an HVAC system, which is going to last 15 to 20 years. So it's almost a no-brainer to try to go down that approach. So that's what we did. We started going down this passive heating and cooling approach. The components of that, is a really good envelope, manually operable windows, exposed thermal mass, like exposed concrete floors, natural ventilation stacks to allow any air when the windows are open to flow up through the building and out through turbine ventilators. That provides the passive cooling along with the thermal mass to kind of pick up the heat. And then the thermal envelope really in the wintertime really keeps the heat in and allows the internal heat gain of people, lights, and equipment to become the heating source of the building. Of course, we also have a little auxiliary heating system just to make sure the space warms up before the people, the teachers and the students come into the classrooms. Next slide. This details, so a lot of the architectural details, particularly how we're building out the walls, detailing out the wall and window where they meet and the corners of walls and so on is really important. And Richard and his team really worked tirelessly to try to get an envelope that works with the HVAC system and this passive approach. It was difficult. We went through a lot of time and trouble, and Richard will say this, but in the end, it was really worth it to get the product that we ended up with. So this is just an example of the peel and stick weather barrier, insulated Z clips, and how that all comes together. The next slide shows another building that's typical with the rigid insulation in there between that gap. That's like a 3-inch rigid insulation, mineral wool insulation there as well. Next slide talks about this concept of balance point temperature. This is what we do to analyze the passive heating approach. So like I said, there's always that internal heat gain of people, lights, and equipment. And that's, when the classes are in session, that's pretty constant. And it's a heat rate. It's a rate of heat that's being gained in the space. So we want this concept of balance point temperature is to say, we want to reduce the heat loss, the rate of heat lost from the envelope to a point where it equalizes the rate of heat gain within the classroom. So if you can get those two lines to mix or to intersect at an outside air temperature that is reasonable, somewhere around 35 degrees or so, then you can say, okay, below 35 degrees, yeah, we need heat because we're losing heat faster than we can make it up. So you need to have some auxiliary heat. But above that, the internal gain is the heating system. So that allows you to really reduce the heating HVAC systems. Next slide. In the passive cooling, though, it's not so simple because there's a lot of factors going on. So it has to be iterative model that's done via computerized simulation. So we provide a data that just like this that looks at different scenarios. You can see we're looking at overhangs to reduce solar heat gain, improve solar heat gain in windows, concrete floors for thermal mass, all kinds of things to try to reduce our numbers of hours above a certain set point. In this case, we're looking at number of hours above 74. So as we go from left to right with these different options, we're slowly reducing the number of hours above 74. And that's the goal of this passive cooling design, which, by the way, ETO pays for that study as well. We also provide heat maps that say when certain temperatures in the space in the classrooms occur. So in this one, for example, this August option. You're seeing that there's in August, mid-August, late in the day, 1, 2, 3 o'clock, you're seeing some temperatures above 80. That's just not acceptable. So you have to do something to get those temperatures down about below 78 or so. Of course, this approach doesn't work everywhere in a complex building like an elementary school, right? So in the green, we're doing this approach in all the classroom areas, but not in the other areas of the building. For example, the admin space was not conducive to doing passive heating and cooling. So we're doing a traditional HVAC system of a dedicated outside air system with VRF. And then the gymnasium, again, wasn't conducive to that either. And we ended up putting in a conventional, just a heating and ventilating system in the gymnasiums. Next slide. This is just a detail, I would say early detail of a natural ventilation stack. I'm trying to detail that out through both the first floor classrooms that's on the right. You can see the stack going up through the second floor, and then the second floor classroom that, you know, it just goes straight up into the classroom. The issue with this particular detail, of course, is that the turbine ventilator was directly above the stack or the opening, right? So in any kind of rain or any moisture that gets into that turbine ventilator would go into the space. So Richard and his team redesigned it to have a little offset in the doghouse on the roof. So any water that gets into the turbine ventilator can actually roll off onto the roof rather than into the classroom. And that was a very important modification to this detail. Next slide. This is just a cool little photo of the turbine ventilators that we took while we were on site. They turn fairly easily on the slightest breeze and helps to induce air up through the classrooms. There's a damper right in the doghouse that will close if we don't want air to come through. But once that damper opens and the window opens, air is pulled through really nicely and provides good cooling. Next slide. And so the way we were able to control this is through a LED sensor. So we have a direct digital control system in the building, looks at outside air temperature, looks at the indoor classroom temperature for each classroom, and each classroom has this LED sensor with a green light. And if the temperatures are conducive outside, that green light will blink. And so the teachers and the students, really, with the cool part is the students, they know that when that light turns green, they can go open the windows, press a button, it opens up the damper and it allows fresh air to come in and really cool the space that way. Of course, you know, we have now events of wildfire smoke and pollution. There's pollen sometimes. So they could elect not to press a button, keep the window closed, and ventilation is still provided through a dedicated outside air system all the time. So they don't need to open the windows to provide ventilation. You'll notice that there's also a heat pump indicated with a thermostat. So this was a last minute add to the design because the district was not comfortable with an expanded comfort range that comes with normal passive cooling that allows the space temperature to get to about 78. They needed it to be 75 degrees. And so what we did was we added a VRF system with heat pumps to every classroom that would come on if we're unable to keep the space at or below 75. So there's a sort of a belts and suspenders system in terms of cooling there. So that's a great, that's an overview of the HVAC system and how we went through the process of getting to a passively heated and cooled building. And I hand it off to Richard.
So the culmination and the integration of all these great approaches to the design solution really turn into a 360-degree review of really what is, how it addresses the communities and the kids that are actually in the building. So next slide, let's start with that one. So these comments match the goals that were established by the school district at the very beginning. Mind, body, and sense of belonging. As I mentioned, most of these people, most of these kids and their families have immigrated from another country. And so these communities could have been disrupted had they not had a new school that really reflected them. And we did that through some community programming and community charrettes to really get the essence of what the community, how they could identify and customize the look and feel of the building. Safety and security, as we mentioned, lots of the normal equipment, the hardware equipment, but also the passive systems of how people get into the building and how they're monitored and how they pass through the administrative offices and then can be allowed to have access to the entire school. Age-specific environments, not every classroom is exactly the same. It varies depending on the age group. Integration of some of the lessons that we're learning about contemporary learning environments with providing a lot of different kind of spaces. In the L-shaped classroom, in the flexible learning space outside the commons, and even some of the breakout spaces for direct instruction off the commons. Student and family services, they do provide services beyond K-5 teaching and learning. They provide these services to their communities and families as a whole. And through that, they do support families and communities with these new buildings. Next slide. So the integration of the sustainable systems really became an important element and really became a point of pride with the school district and the schools themselves. All the materials were scrutinized at lengthy conversations about their durability and their maintainability. The school district really has to carry on with these buildings beyond just when they open. Energy conservation was a priority. That's why they listened to what the design engineers were offering in terms of really sustainable practices. Sustainable sustainable in the sense that not only the first cost savings, but long-term cost savings and energy conservation. High performance buildings, the creation of this exterior envelope was really a great task of really having R40 on the walls, R50 in the roof, and then a very tight exterior building so that air penetration just didn't get in and offset the conditions of the outside temperature coming inside. And then the integration, as Ruan mentioned, the integration of the kids into the controls of the buildings with the monitoring of the green light is always a fun thing, and kids, it becomes second nature. When they first move in, they really love it, but after that, it becomes just normal everyday activity. And that's what we really want, is to give these kids and these students an opportunity that the sustainable practice and the customization of these schools are really meant to serve the community and the kids in that community. I think that's what we've got for you today, and hopefully we have the opportunity to answer some of your questions.